Now, the second part of this question on Penny's pattern is about consecutive terms in the pattern, the difference between consecutive terms. Now, in essence, when you're talking about the difference between consecutive terms, you're talking about the second difference, right? The second difference. Because that's the difference between consecutive terms. So between 1 and 2, so term 1 and term 2, you get a value of 2 and 6 for the number of tiles. The difference between those is 4. And for between 2 and 3, the difference is 6. And between 3 and 4, the difference is 8. So you're actually looking at the second difference, and you're looking at what that pattern means, what the rule for that pattern is. We know that it's changing by 2. The second difference is a change of 2. But how would we actually show that relationship? So one of the easiest ways to show the relationship is just to make another table. And in that table, this is going to be this is difference in the first 2 consecutive terms, the second consecutive terms, the third consecutive term, the fourth consecutive term. So in between 1 and these, right, 1 and 2, terms 1 and 2, so the consecutive terms is 2 and 6, like when we get the values, is 2 and 6, that's the number of tiles. The difference is 4. So for the second difference between the consecutive terms, between 2 and 3, the difference is 6. And the third difference between 3 and 4, the difference is 8. And the fourth difference between 3 and 4, 4 and 5 is, terms 4 and 5 is 10. Right? So this is sort of the second difference, if you will, second difference. And this can be like the first set of consecutive terms. So this is, the consecutive terms. So this is the first 2, second 2, third 2, fourth 2. There's a number of different ways you could do it, but I think that will work. And then, well, we see that the difference is 2. So we know that we're going to take this term and we're going to times it by 2 and add 2, times by 2 and add 2. So the pattern here is basically for the difference in the terms, second difference in consecutive, the difference between 2 consecutive terms is the second difference. And the pattern for that is 2n plus 2. Now, you could graph that against the other pattern, which is n squared plus n. So one's a quadratic, one's a linear function. But you can see that if that's the relationship in the second difference, it's always going to be even. So for any n value can make any value of n. When you stick it in to here, it's always going to give you an even number. Always gives an even number. Can't give an odd number. Whatever n is, if I stick it in here and I add 2 to it and times it by 2, I'm always going to get an even number. That's the easiest way to do that question. Not the only way. You can take a look at what the other option was for doing that, but I think that that's a much harder option than this one.